All right, in this video, I'm going to be working 2021 BC number 2. This will be the second problem on the free response for the operational version of the AP Calculus BC exam. So they say for time t greater than or equal to 0, particle moves in the xy plane with position x of t and y of t and velocity vector given by basically what I'm going to call x prime of t and y prime of t, t minus 1 e to the t squared, and sine of t to the 1.25 respectively. And I think just knowing how this goes, clearly been doing number 1 over there. Based on how I know these parametric equations free response questions go, I'm going to put this in y1 and I'm going to put that in y2 just preemptively, right? So I'm going to say x minus 1 times e to the t squared. And then in y2, I'm going to put in sine of t to the 1.25. And I'm going to stay in function mode because I'm honestly not interested in what the graph of velocity vector versus time looks like. That's what would happen if we did x of t and y of t there and switch it to parametric mode. That wouldn't help us at all. And we probably wouldn't be able to run those same good intervals that we can here. All right, so I see speed and total distance, and I know both of those have to do with that square root. So I think what I'm going to do is I'm going to actually, right here, do the square root of y1 squared plus y2 squared. Okay, so I just know that y3 is like the speed function. So when I go to find the speed, I can just plug 1.2 into y3. And when I go to find total distance, I'm just going to integrate y3 from, 0 to 1.2. We can do that. All right, so the first things first, speed of the particle at time t equals 1.2. What are we going to tell the reader that we're doing here? We're going to tell them that we're taking the derivative. Oh, no, we're not taking the derivative. They already gave us the derivative. Before I even do that, I don't remember to point this out, I'm going to very clearly state at the beginning of part A, or maybe just somewhere on the page, like on your actual free response, you're given kind of like a box you have to write in. But I'm going to clearly say, let x prime of t equal t minus 1 e to the t squared, and y prime of t equals sine of t to the 1.25. And I'm knowing that within all likelihood, if you call x prime of t and y prime of t, they're going to know you mean these things. But they called it the velocity vector. They didn't ever say that this was the derivative of x of t and this was the derivative of y of t. And so I want to show them that I know that that's what's happening, but I don't want to copy this down every time I want to say x prime. You know what I'm saying? Like, we don't want to do that. So for part A, I'm going to say the speed of the particle, speed at time t equals 1.2, is going to be equal to the square root of x prime of 1.2 squared plus y prime of 1.2 squared. Oh, just enough room. And then I can go, and I can already set up to be able to do that really easily in the calculator. Oh, no. Okay, so here I am, right? It's in y3. I just want to plug in y3 of 1.2, and I'll get 1.271. Okay, great. Love that. Okay, then for the acceleration vector, well, the acceleration vector at time t equals 1.2 is going to be equal to, well, I guess, say x double prime of 1.2 and y double prime of 1.2. Okay, and we can find these values using the calculator, using the numeric derivative functionality, right? I'm going to use math 8. So I'm going to use math 8 on y1 is x prime of t at 1.2. And I get 6.247. And y double prime of 1.2, I'm going to do the same thing, except maybe I'll move it over here so you can see what buttons I'm pressing. I'm going to press second and enter to bring up the same exact thing again. Okay, because all I need to do is change that to y2 and press enter. I got myself 0.405. Something that I definitely should have checked before I even did this one is when I was typing in this one, and particularly when I saw myself typing in sine, I need to check to make sure I'm in radian mode, especially if you use a borrowed calculator, a shared calculator, or something like that. We need to make sure we're in radian mode, right? So I'm going to do that, and I'm going to, I'm just going to scratch on my finger or something, it looks like. Oh, I remember that. It's from a cat. All right, for part B, total distance traveled. Distance is going to be the integral from 0 to 1.2 of that same square root, x prime of t squared plus y prime of t squared dt. And I can run this through the calculator, right? Put that right here. And I can do the integral from 0 to 1.2 of y3 dt. And 1.010 or 1.009, depending on what you want, how you want to write that. Then for part C, this is one where we're going to have to do some explaining, right? Find the coordinates of the point at which the particle is farthest to the left for t greater than or equal to 0. Explain why there is no point at which the particle is farthest to the right for t greater than or equal to 0. And let's see. Yeah, what I want to do to show you why this is the truth is I just want to look at dx dt. Just want to graph that. So I ungraphed the other ones, and we're interested in t greater than or equal to 0, so I might just go and do this. Kind of the more default window. But I'll make x or t start at 0 and only get bigger. So here we are. And it's like, oh, okay, I see what's happening, right? E to the t squared is going to really just kind of explode. And that's what we're seeing, is exploding here. But at t equals 1, dx dt is equal to 0. And then for t less than 1, dx dt is negative. Which means that in terms of like the path of the object, it's going to start off, it's going to be going, I don't even care about whether it's going up or down, just on a left-right level. Just on its, east-west position. It's going to go to the left until t equals 1. That's where x is going to stop decreasing and start increasing. And then it's going to really start going fast to the right. Okay. So I'm going to say, I forgot how I wrote this morning. I already did this problem once. But let's say x prime of t is negative for 0 less than t is less than 1. And x prime of t is greater than 0, I might say for all t greater than 1. Okay. Meaning the object is farthest to the left at t equals 1. Okay. So position at 1, oftentimes we use s, and at least in AP Calculus, s of 1 is going to be equal to x of 1 and y of 1. Okay. Forgot, we don't really integrate vectors in this class. So what we're going to do is I'm going to say x of 1 equals x of 0, which they told me was negative 2. Plus the integral from 0 to 1 of x prime of t dt. And y of 1 is equal to y of 0 is 5, plus the integral from 0 to 1 of y prime of t dt. Now this is something that I'm going to need to bring in the calculator for. All right, so let's do negative 2 plus 0 to 1. X prime was y1. That's going to be negative 2.604. You see that? Yes, it's just still right in on the page. Then if I change that to y2 and this to positive 5, I would have 5.410. Okay, so I found the, I might, if you were unsure, You just wanted to be safe. Farthest at the left, t equals 1. Reason why is what I just wrote above that. I really don't think that needs any further justification. And so then that gives me my position. Okay. Why is there no farthest right point? Well, and this one, I'm sure that when they release the scoring guidelines, there's going to be some sort of like really obvious way I should have said this. But I'm going to say because x prime is negative and then positive, and that's the only sign change. Which, of course, is not really saying anything I didn't already say up there, but I'm just like directly answering the question of why there's no farthest right point. Has just one sign change from negative to positive. At t equals 1. And that's going to be it. Right, because t minus 1 only ever changes signs at t. E to the t squared is always positive. So that's what I'm going to say for that. All right, and so that's number 2. That's the parametric equations problem. I think this one was really friendly to us, if we were to have to take it.